Hello. In this video, we are going to be deriving something called the quotient rule. The quotient rule for taking derivatives. There we go. So the quotient rule is kind of a method of taking derivatives that you can use given the function we have. Well, when you're meant to take the derivative of a quotient of two functions, so where our greater function can be written as f of x divided by g of x, and we're meant to take the derivative. So the derivative with respect to x of f of x divided by g of x. Alright, so what's special about this quotient rule, and why am I deriving it instead of just telling it to you? And I mean, this can go with all of the different rules, but with the quotient rule in particular, it's not that unique. The quotient rule is kind of a unique form of, and I know I just said it was not unique and then unique, it's a specific use of the the product rule. You can use the product rule to do any quotient rule problem, just perhaps for some problems, the quotient rule is a little bit easier. From my experience, I almost always use the product rule just because it's a little bit easier to remember, but it's important to at least know of the quotient rule. So when we're meant to solve this, what are we going to do first? Well, we can write this as the derivative with respect to x, using the product rule, of f of x times the function 1 over g of x. So now we've basically turned this into two separate functions where 1 over g of x can kind of be represented as an outer function and inner function, where g of x is our inner function and 1 over x, you can pretend that was x, that's our outer function. Alright, so let's move forward with this, and I'm going to switch colors. So what is this going to be equal to? Well, given the product rule, that's going to be the derivative of the first function, f prime of x, times the other function, so just over g of x, or times 1 over g of x, we can write times 1 over g of x, plus the normal first function, so just f of x, plus f of x times the derivative of our second function, which is 1 over g of x. But how do we take the derivative of this? It's not g prime of x, since this isn't the function g of x, it's 1 over g of x. So instead, what we do is we use the chain rule to take the derivative. So we can rewrite this, and I'm going to bring this over here, as g of x to the negative first power. And now what we have to do is take the derivative of the outer function. What you should know is that, let's do green, the derivative with respect to x of x to the negative first power is equal to, right, this is just a power rule, bring that exponent down as a coefficient, and then subtract 1. So subtract 1 from the exponent. So this is going to be equal to negative x to the negative 2, or negative 1 over x squared. So similarly, we have g of x to the negative first power, and knowing the chain rule, we take the derivative of the outer function, negative 1 over x squared, and then plug in the inner function. And then we multiply by the derivative of the inner function. So we can rewrite, we can add to our solution here, f of x times, oh, that's not quite the color I bargained for. Let's do a bit of a darker orange, yeah. Times negative 1 over g of x squared, right? Because we take this derivative here and then plug in for g of x when we do the chain rule, but then we multiply by the derivative of the inner function. The inner function is g of x, so this is g prime of x. And this is our result. We're not done yet, though. So we're going to write this out as f prime of x over g of x plus, what is this? F of x g prime of x over g of x squared. And I'm going to make some space down here so that we can finish simplifying this, because there is a final kind of standard simplified form that if you are going to memorize instead of just knowing how to derive it with the product rule, it would be good for you to see. So that final form, right, we can, let's make like denominators. So this is going to be equal to f prime of x times g of x, right, just multiplying g of x by the numerator and the denominator, over g of x squared plus f of x times g prime of x over g of x squared. And of course, we can just combine them now so that we have, oh, I'm sorry, I forgot the negative altogether. So I forgot this negative over here. That's a mistake. There's a negative between these functions. It's very important. I had this -1 up here, and when I added them, I forgot about that -1, so this really should be a subtraction. It's very good that I caught that. So this is going to be f prime of x g of x minus f of x g prime of x divided by g of x squared. And I hope that doesn't look too messy there. But essentially, what our final answer will be for the derivative of this expression here, f of x divided by g of x, is going to be the derivative of f of x times g of x minus f of x times the derivative of g of x divided by g of x squared, where these g of x and f of x are functions, which I think is why that can get confusing. And since I did get kind of near the edge, let's just write this out in one final expression here so that it's more clear. This is all going to be equal to f prime of x g of x minus f of x g prime of x divided by g of x squared. And these two are equivalent. So this is just essentially another way of doing the product rule when you're dealing with functions. When this method might be a little bit easier, I haven't come across that a lot. I usually just suggest using the product rule as it is. However, if for whatever reason this one is easier, I thought it would be important to tell you all about it should you need to use it. This is the quotient rule for taking derivatives. Thanks for watching.